So, hi everybody, I'm Adrian Cockcroft. Some of you know me as the guy that wrote that book for Sun, but with a Porsche on the front, about, I don't know, 30 years ago or something. Okay, thank you. There was a few in the audience. And then I worked for Netflix, and you probably are fed up with me talking about Netflix for most of the last decade. I spent the last 5 years working for Amazon, again, explaining Netflix to people, helping with cloud, helping with open source. And about a year and a half ago, I joined the central Amazon sustainability team. And we did a few things. We got a well-architected guide for sustainability out. I helped get the carbon footprint monitoring tool out, which I'll talk a bit about later. And most recently, there's a sustainability data initiative. There's about 100 petabytes of free data sitting in S3 that we don't even charge, or AWS doesn't even charge for using the data, like there's no egress charges and things. It's all zeroed out cost. All the sustainability, satellite modeling data you might want to need. So I helped run that, and we just did a little relaunch of that at the Remars project. So that leads me into today. I resigned from Amazon beginning of this month, so about 4 weeks into retirement, whatever you call that, which for me is going to be advising people, hopefully about things like sustainability and monitoring carbon, a little bit of consulting, and taking lots of time off when I feel like it. So that's the theory. We'll see how that works out. This is one of those talks which is kind of like a fire hose of this is all the shit you need to know. Like just to sort of blast you. So hopefully it'll keep you awake. I'll go pretty quickly through this because I've got to jam a lot of things into half an hour. Some of the talks are a bit more conceptual, but this one is just, I'm assuming you understand monitoring and you probably don't really know that much about carbon and what's going on in sustainability. So we'll go through that. So we are all collectively used to reporting and optimizing throughput, latency, utilization, capacity, maybe cost, things like that. That's standard monitoring stuff. But carbon is really just another metric for monitoring tools to report. So that's what I'm pushing here, is that eventually you're all going to be dealing with carbon as yet another metric somewhere in your dashboards. And the reason this is going to happen is the regulators are forcing it to happen, particularly in Europe. If you've got customers in Europe or you have anything going on in Europe, they have legislation that's enacted, which is happening, which is forcing this to be a topic right now that people are grappling with. They've got to measure next year and report it the year after, which means you've got to set up the measurements this year. The US is about 2 years behind that, but then everybody is also doing under market pressure to do more here. And you've got to decarbonize all your products and services. So how do you do that? Well, first you need to know how much carbon you're emitting and where it's coming from so that you can then go after the big bits and ignore the little bits rather than just randomly starting with the first thing you find, right? So, little question. Do you know how much carbon your company emits for, let's call it data processing and hosting each year? Does anyone here know what that number is? Any guess? I figure not. So how can you get to an answer? So how about how many dollars you spend on data processing? Just call it IT. What's your IT budget? People generally, you could go to somebody in finance and find out what your IT budget is if you don't know, right? Some of you might be VPs that know what your budget is or whatever. Let's just say it's $1 million a year you spend on IT. All right, that means you have 159 tons of carbon, which is like crazy. What? How? Well, what we've got is this economic model where you basically say, if you know how much you spent, we average the industry and we come up with an average number that if you spent $1 million on cardboard boxes or IT or jet fuel, this is how much carbon it is just based on how much you spent. So this is the economic model for carbon. And you go and get these numbers, and if you're an auditor and you come in and say, well, where did you get your carbon numbers from? You say, well, we got the number from finance and we got this other number, which is an EPA number. So that's a good number, and it's for the right year. It's for 2020. It was calculated from 2016 data, which doesn't sound that great. And it's for use in the US only, and it tells you 159 grams per dollar, which is the same as 159 tons per $1 million, right? There are numbers like this for just about anything you might ever spend money on. You can go to somewhere, there's multiple places to get it from. Climactic.io is one of the places if you just Google these numbers. So these are called emissions factors. So the economic model for carbon, you break down where you're spending all your money, you find the right emissions factor, multiply, accumulate, and you're kind of done. So there's good things about this. Everyone uses economic models, really. Most of the numbers you see about how much carbon a company is emitting is actually from an economic model today, right? It gives you a really big picture, really approximate view. You can always get the input data from finance. These emission factors update every year, so you just got to pick the right year, the right country. Auditors can trace the calculations. This is going to be audited data. Carbon is going to be audited like money is. Right, the auditors are going to come in, the board is going to sign off the carbon number for your company. So this is going to be like financial reporting. And it estimates the entire life cycle of what it took to make the thing as well as what it used to operate it. The bad is it's a very coarse model. They're based on old data. It can be hard to find the right factor. And if you spend more, carbon goes up. Even if you spent more to reduce carbon by buying something, spending money on a low carbon thing that costs more, you'll get charged more carbon for that, right? So, and a lot of the optimizations you might think of that are cost neutral have no effect on the numbers, right? So that's not good. And then one problem is if you do an economic model 1 year, and then the next year you go, oh no, I've got real data this year, I'm gonna have a better number, and I've also saved some carbon, but your numbers may go up. And that's because if you're really efficient at buying hardware and computers keep getting cheaper and faster, that means the old data from 2016 is actually an underestimate, because the dollars you spend per computer is actually going down. So, but the carbon is staying about the same. So start here, use it when you've got no other data, but everyone starts with this to do the whole company, big picture, where are the big chunks of carbon coming from? That's the economic model. Then you take those big chunks and drill in and do a process model. Before you do that, I'm going to do, so by the way, my slides, you may have noticed, have this picture of the moon gradually moving across, because otherwise they looked really boring, and I had some pictures. The moon has nothing to do with this talk other than that I like taking photos, and I used to have a budget for making really cool looking slides, and now I don't, all right? And this is what the slides looked like when I had a budget for it. And I stole these from one of the other decks I got made. So scope 1, you hear about these scopes of carbon. Scope 1 is the fuel that is consumed, and if you buy fuel and burn it in your car, or heat your house, or cook with it, that is your scope 1, right? You figure out how much fuel that is. And if you electrify everything, you can get rid of scope 1. Scope 2 is the electricity use. Technically it's the energy, but almost all purposes, just think of it as the electricity. And the things you have to think about is where does it come from? That's called the grid mix. How much is renewable, how much is fossil-based, carbon-based? And then what do you do with it when you get it? Well, if you put a heat pump in your house and put some solar panels on and some batteries and an electric car, then you're kind of doing all the right things. And maybe you switch to an induction range, which, because gas ranges actually cause indoor air pollution and a bunch of other things. So that's scope 2. Scope 3 is everything else. So scope 1 and 2 are not double counted. They are unique to you. Once you've counted that, that's it. Scope 3 is actually double counted because it's somebody else's scope 1 and scope 2 is your scope 3. But what it means is you can't just export your problem by just outsourcing it, because that outsourcing is actually counted against you. Everything you've outsourced in your supply chain is counted as part of your scope 3 because you're influencing it by choosing who to buy and where to buy from and all of the things you do. But this depends enormously on what kind of business you're in. So let's just zoom in on data centers. So you've got grid mix, so that's scope 2 coming into your data center, comes in with some power pylons. Any fuel you burn in a backup generator, that's scope 1, okay? And then scope 3 is the data center itself, all the concrete that used to make it, all the racks and all the machines and how they were made and all that stuff that comes in, okay? If you zoom in a bit and look inside the data center, you find that power goes through lots of stages of power distribution with some losses. It's used for cooling, then it powers the racks that do the work, okay? So what's going on is that your suppliers need to report scope 1, 2, and 3 to you, and you need to report scope 1, 2, 3 to your customers, right? So that those people in Europe, they have customers and suppliers in the US. So if you're just thinking, I'm in the US, I don't have to care about Europe for a few years. If you sell something to Europe, all those people in Europe are going to be bugging you for your scope. Even if you don't need to do it for the US rules yet, the European rules are going to spread around the world through the supply chains, right? That's the problem. And if you want to get into detail, greenhousegasprotocol.org is where you get this. So let's look at a process model. And so instead of dollars, What we're going to be looking now is kilograms of materials or kilowatt hours of energy. You measure them, find the emissions factor, same deal, right? But what we have here is something called a life cycle analysis, LCA model, which is basically cradle to shelf or cradle to grave, depending on how you think about it. But fundamentally, the supply chain for manufacture and delivery of that machine that you've got in your data center, the energy used to run it, and then what did you do when you disposed of it? Now, if you can keep machines for longer, use them for longer, say your phone or your machines or whatever, you're actually increasing the amount of use phase, and you're decreasing the proportion of the embodied carbon of how to build it and remove it, right? So the proportions are better. So you want to use things for longer, but you also potentially want to replace things with lower power devices when they come out. So you have to balance that. So great. Models are available, expertise is available, it's reasonably detailed and accurate. Energy data is fairly easy to get in general. Optimizations actually work, and auditors can trace these. Problem is, these are still averages for a business process. It's not measuring that individual machine. It's the average across all the machines in a data center, that kind of level. It's a lot of work. The supply chain recycle data is hard to get, and quite often people just can't figure out, scope through, and just leave it out. They just focus on the energy use. And if you really focus just on the energy use, hey, I've cleared out, I've bought green energy, my carbon is 0, I'm fine, we're 100% green, and get, hey, look, those machines have chips in them that were made in Taiwan. Taiwan is pretty much 100% coal-fired electricity when they make those chips, sorry. SSDs are almost entirely manufacturing carbon. Like there's very, very little energy used to run an SSD, but an enormous amount of energy used to make one. CPUs are the other way around. It's mostly the energy used to run them versus, so lots of things here. So build LCA models, start with energy, don't forget the rest of the cycle. So how hard could it be to measure the workload of a machine? All right, so let's think about this. We've got this sort of zoomed in machine. So first of all, we get the grid mix from the local utility, comes with the utility bill, usually a month or so in arrears. But then you also, if you're a large cloud provider in particular, you have power purchase agreements and renewable energy credit purchases. And I'll explain what those are in a minute. So that's the energy coming in. You've now got a mix, grid mix. Now you have the power usage efficiency. So how efficiently does that energy deliver to the machines in the data center, taking into account the cooling? And quite often, like if you're in Singapore, for example, your PUE is likely to be around 2 because it's hot and clammy, takes a lot of work to keep everything cool, and the machines aren't that clean, and the data centers aren't that efficient. If you're talking about a large-scale cloud provider data center, then it's sort of 1.1, something like that. So you can get some very efficient data centers where it's maybe only 10% overhead. But it actually depends a lot on the architecture. So what you can say is the scope 2 carbon of a workload is going to be the power mix and the PUE, the capacity you're using to run the workload, and then sort of the emissions factor for that capacity. Different emissions factor for storage or compute or network or whatever you're doing, right? So there's a few problems with this. I'm going to have to zip through this pretty quickly. Power mix. Delay, the bills are going to be delayed by at least a month. If you get into some of the developing world, it's longer than that. Power purchase agreements are contracts to build a wind farm or a battery farm or a solar farm. Amazon has over 15 gigawatts of these. I think Google has about 7 gigawatts or something. Most of the large cloud providers have somewhere in the sort of 10 gigawatt-ish ballpark amount of of power that they've contracted to build. Right? You pay the money, somebody builds a new wind farm. Renewable energy credits are kind of like that, except somebody already has a wind farm that they haven't contracted to sell it, and when they do the electricity, you can sort of buy the rights to the renewable energy, right? So you're just sort of paying a little bit extra to say, I'm claiming this renewable energy that you're generating, right? So it helps fund existing things. And they're basically used to top up the market. The market for RECs is much smaller than for PPAs, and it's used to top up around the edges of things to get to 0 or whatever. The grid mix is getting better over time, but it changes every month. It really changes every hour, and we're starting to see 24/7, particularly from Google and Azure and FlexiDAO, who are implementing sort of a 24/7 exchange. AWS hasn't talked about this at all yet. And there's a tool called Cloud Carbon Footprint, open source, that has a bunch of estimates in it which don't take into account all these PPAs, so the estimates are really not that useful. It's useful for other things. PUE, not well standardized. It's useful to compare data centers within an architecture, but once you get to like distributed backup batteries and things, you get different numbers based on how you've set up your data center. Capacity. Well, hey, I've used a machine. I know that's a machine. Okay, that's good, right? But I know I used an instance. Well, that's part of a machine. But what about the hypervisor? Did that get included? What happened? You know, how do you slice and dice these things? And then you get into shared services where you have no idea, like how much Kinesis are you using or whatever, your MongoDB Atlas or something like that. You've got all these shared services that you might want to deal with. So they're hard to allocate. But if you are yourself providing a multi-tenant SaaS service to your customers, then they're going to come in and say, well, how much of your carbon footprint do you allocate to us? So everyone's got this allocation problem, and some people are going to have to go solve little algorithms that say, this is like your overhead plus this is the amount per customer, and this is how you're going to partition it out. And then we get to the emissions factors, and some of the data you can figure out, some you can't, but it depends. You've got to know what instance type it is. Is it a GPU? Is it an Intel? Is it an ARM chip? The ARM chips use a lot less power. The GPUs use a lot more, obviously. What storage class is it? Are you on tape? Tape's a really good storage class. It's basically just sit on tape. Doesn't consume very much power at all. So they're really low carbon. And there's all these other things, like what's the utilization? Like the actual power consumed by a machine increases as you make it busier. So there's a lot of confounding things in here. And some data's available for some systems, not enough, and this is the real problem we have right now. So what can you do today? So the moon is great. Basically, I set up a camera outside with like my phone hooked up to it and push the button every now and again so I didn't have to go out in the cold, so the moon sort of gradually worked across. So if you're trying to report something that's going to be audited, like your board's going to sign off on the numbers, you've got the cloud vendor reports, on-premise economic models, and these are sort of more accurate in some sense, but they're less useful for tuning, right? They're accurate in the sense that the auditors will sign off on them. So this is the kind of state of the world for cloud vendor reports. AWS is this customer carbon footprint tool. It's part of the billing console. You just scroll up in the billing page and you'll see a bunch of stuff about carbon. If you're a pretty small account, you'll just see zeros there. If you're a fairly large customer and if you have stuff going on in Asia, you'll see it quite a lot more. The European, US, this is really just scope 1 and 2 as well. We don't have any of the supply chain figured out for AWS and most of the other vendors either. US and Europe, and Europe and US based regions are pretty close to zero right now for pretty much all the cloud vendors. The numbers are reported a bit differently here and there, but that's kind of what's going on. Asia, it's very hard to buy PPAs in Asia. It's very hard to source green energy, renewable energy. So that's when most of the work is currently still happening. Azure, there's the Microsoft Sustainability Manager. It's part of their Dynamics product, which is a commercial product that you pay for, and I don't think there's a free thing they have. Maybe there is, but it looks pretty much like they're pushing people to go pay money and use Dynamics. High resolution, like the AWS data is very low resolution. I've left now, so that you're still hassling them to release more data, right? So that's kind of what's going on at AWS. Azure already has very fine-grained data out there already. These are both market-based, and I'll explain what that means in a second, but GCP is using location-based, and the numbers just aren't comparable. It's a totally different way of calculating the carbon, but they have a nice API and a tool and a lot of data. So if you're going to build a workload optimization product or a service that sits on top of carbon data, really, Google's really the only place you can do it right now. They have an API and lots of data, you can go do it. There is no API to the AWS stuff, and it's not high enough resolution. And the Microsoft stuff, you're kind of getting into how do you hook data out of Dynamics or something like that. So market versus location. So CO2 is globally mixed. If you measure CO2, anywhere in the world other than sort of, in general, it mixes very clearly. So if you save some carbon here, you can emit carbon somewhere else, and it offsets in terms of the total carbon in the atmosphere, right? So that's the idea of like offsets. But as we get better and better at reducing carbon, what we actually have is that the easy to reduce things gradually get used up, and we end up with the difficult places are left. So it actually is better to do the more difficult ones and start working on those now, otherwise we won't have time to fix them. So a power grid is a market for energy. And if you remember that Texas having that big freeze-up thing they had last year, whenever that was, that's because Texas is an energy market and they don't interchange power with the rest of the US. There's actually 3 energy markets in the US. So what that means is if you do a PPA to build a wind farm in Texas, somebody somewhere will shut down a coal-fired plant or a gas plant because the power is in Texas. Right, so that's what's meant by a market-based sort of accounting. So what you're looking at is because you have, say, a data center in Texas, you have the energy you buy in Texas that goes into the Texas grid counts towards that one, but it doesn't count towards what you're doing in Ohio, for example. Right, so that's the market-based thing. And some people kind of take a global market. It's kind of Google have been talking about that for a while, but they're getting now to something even more local because they're looking at hourly data by location. So again, the Google location data, by the way location is defined, you can't include your power purchase agreement, so their data comes out differently. So it's just a mess right now, sorry. This is an interesting, if you go look on the Google site, they've got something, and this is generally what you'll see around the world in terms of grid mix and time of day things. The interesting thing, if you look at Singapore, it's only 3% renewable energy in Singapore. Singapore is too small to have lots of solar panels and wind farms. There just isn't enough land. And they have basically dirty energy in Singapore, and everybody has that problem, right? This is not, the map for Azure and AWS would look very similar with different regions in slightly different countries, but it really looks very similar. Asia's the problem, and we're going to be fixing that in the next 4 or 5 years, I think. All right, so if you're trying to do something here and you want to optimize a workload to reduce its carbon, how are you going to do that? The stuff you're getting from the vendors isn't that useful, but there's this thing called the Cloud Carbon Footprint Tool, there's a thing called SCI from the Green Software Foundation, and these are not accurate in what, don't believe the amount of carbon they tell you, but they are directionally, proportionally good. So if they tell you they're saving 30% of your carbon, they probably are, but the actual tons of carbon will be wrong, right? This is what the Cloud Carbon Footprint Tool looks like. So I would use it for tuning exercises within a region. It does produce things that try to compare. I mean, it attempts to compare cloud vendors across regions and across vendors. It's just that it doesn't know the PPA data, so it's just the numbers are just wrong. And they don't have a way to fix that now. As more transparency comes out from the vendors, maybe after a while we'll be able to calibrate that in, but that's really the state of the art. But within a region, if you're trying to tune a workload, this is a good tool. Okay, Green Software Foundation, the idea here is that you have carbon per API call or per transaction or per unit of work, and you can start figuring out that as a metric to actually report into your system. So it's kind of trying to get that fine grain, unit of work, kind of mile per gallon kind of level of detail. So just some opinions across the cloud providers. I don't think right now there is that much difference. Like you shouldn't really be thinking about moving a workload between cloud providers just to reduce carbon. They're all roughly the same in a region. Everyone's got a problem in Asia. The rest of the world, it's pretty much low carbon already. And the scope 3, the embodied carbon to make a machine, it really doesn't vary that much. You've got the same RAM and CPU in most of the systems, right? But there's big differences right now in tooling and transparency. AWS is the least transparent. Google's got the best tooling. There's just huge differences. And I think over time these things will gradually come in. But right now, there's a lot of customers that are going to want an answer. So if you're a monitoring tools vendor, I think there's a lot of opportunity here to just gather this big mess together and say, okay, we're going to come up with some numbers which we can try and come up with. If they're auditable, that's good. If they're good for optimization, that's a different workload. So I try and separate sort of what you want to do for audit from what you want to do for optimization. So hopefully that was a useful intro. DM me or whatever if you've got questions. I'm going to be around through the end of Tuesday, so happy to talk to anybody about this. And now I guess we're kind of done and you can go and enjoy yourself for the evening. Thank you. Any Q&A? Looks like we have a few minutes.
Yeah, we have a few minutes.
Yeah.
Clarification question. So when you say that a lot of US and European cloud providers are carbon neutral, does that include scope 3? So
No, this is just scope 2, it's energy use. So over the last few years, all the cloud providers have been buying gigawatts of power and more batteries so that you've got storage to carry you overnight. But lots of solar, lots of wind, and that has neutralized out the grids, what was remaining in the grids in different countries. I mean, if you look at France, it's like 90-something% nuclear energy, so you don't need to do much to zero that out. Similarly, Sweden's pretty good, the UK's pretty good, in somewhere, Dublin or Spain or whatever, you put in the solar and it zeroes it out. So there's these kinds of things have been dealt with. And last year there was still a fair amount of work to do. This year I think we're pretty much reaching the point where just about everybody, when you do that little carbon report on AWS, you're going to get zeros most of the time in US and Europe for your carbon footprint. But that's in the market-based model, not taking account of time of day. Right, so they're generating extra power during the day, and they're using they're using power at night. So there is still carbon being used, but that's kind of where we are right now in terms of the sort of state of the world. More questions? Yeah.
I'm just wondering. You're talking about data centers, but when companies, for example, do a lot of traveling or flying around the world, how does that come into this?
Yeah, so they're talking about travel. If you're looking at different companies, I have one example, like a couple of extremes. I did a talk on the well-architected guide, and we had Starbucks come in and do a little section in there. I think from memory, it was about 1% of Starbucks' carbon footprint comes from IT. 20% or something comes from milk, right? So if you want to help save the world, drink oat milk. Oat milk lattes, whatever. Switch to oat milk at Starbucks, it'll help them, right? So what you find is like 99% of Starbucks' carbon footprint is the physical world and 1% is IT. If you pick, say, a SaaS provider that just does nothing and is a fully distributed organization, doesn't have any offices, pretty much their entire carbon footprint could be their cloud bill. Right? So you've got to figure out where are you in that extreme or somewhere in between, right? As soon as you have any physical things like buildings are a big chunk of the carbon footprint. So if you're a SaaS provider with an office, that office is going to be most of your carbon footprint. Travel and transport is a big category as well. Flying one person to Europe is about a ton. I think a round trip is about a ton. So think of that as sort of what is a ton of carbon? It's a round trip to Europe. It's like a ton and a half or 3/4, depending on where in Europe and US you started. But it's order of magnitude, that is a ton of carbon, right? And we're trying to get to sustainable jet fuel based off green hydrogen that's generated through electrolysis, and then you can sort of fly for less, right? So that's what the airline industry is working on right now. So yeah, travel and transport will quite often be a large component, but proportionately, it's probably smaller than buildings for most people, and commuting and all these things. So all this work from home stuff is helping the planet a bit, but then people are going on vacation more. So I don't know. You gotta take it where you can. One more? Yeah.
Okay, and we'll get you next. Go for it.
For the legislative or policy forces, how do you think the European stuff is going to have more effect than the new SEC rules, or where do you see those taking?
Okay, so the European rules came into effect. They were signed in last December. You have this year to figure it out. You have to measure next year, and you have to report it in 2024. And this is on the books. right? So these are decided. What's happening in the US right now is the SEC is looking at some similar rules, which are going to be different, just to make life interesting, but are going to be similar. But so if you operate internationally, you're going to have to figure out how to do both kind of rules. And the details of why they're different, but it's sort of, think of it as sort of the US is doing sort of a bottom-up, what's practical approach, and the Europe was doing a top-down, this is what the world needs approach. So they're sort of meeting in the middle, mostly the same, but with some detailed differences. So the US is probably 2 years behind, but like I said, the supply chains of Europe are going to touch the world faster than the US sort of gets its act together. So the large corporations that are international are all scrambling right now to figure this stuff out.
There was one up top now.
One up top, yeah.
As the power trade and the energy consumption becomes more and more one, do you think that this will cloud provider will start charging for energy use instead of keep time, or will that remain extracted?
So the question was, will the cloud providers start charging for energy use? In general, the PPAs are cheaper than buying energy on the open market. So the cloud providers are getting a discount by buying renewable energy. And that's just, then there's no separate charges. If you want to get into a bit more detail, the well-architected guide had some ideas in it about not running your cron jobs at the top of the hour at the same time, because that causes a big spike in load, which causes you to need more capacity, so you should jitter your cron jobs around and things like that. But there are some ways that you can help the cloud providers not need so much capacity and move things around. You know, you could think about playing games like biasing the spot market to use less carbon or something like that. But those kinds of things are sort of still speculative. And Google's got some things where they do sort of follow the sun. You want to run your training workload, your big GPU training workload, wherever it's sunny because it uses less energy. But then you have the capacity still sitting there burning energy. Like, just because this GPU is not being used to run your workload, it still exists. So most of the carbon is there anyway. So it doesn't make a huge amount of difference to do follow the sun. I would just run your workload where you need to be. And in the next few years, all the cloud providers will get green energy everywhere in enough volume that it won't be an issue.
I was going to say there was one more question here.
Okay.
Yeah. So from an auditing perspective, using the economic model of there's some multiplier of what you're using, is there any value in being more granular in that end? Instead of just saying how much you spend on cloud, like, this is how much you spend on networking or on egress or some very specific pieces, and saying it's more expensive to do networking from a carbon perspective, just in an auditing sense, being more granular.
Yeah. Yeah, so the question is, can you get a bit more granular with the economic model? If you can come up with differences across your suppliers, but you can still use dollars as the denominator, if you like, right? But then you can basically say, okay, if I'm buying delivery services like Amazon does, there's UPS and there's the Amazon owned delivery, and then there's like UShip or whatever, right? There's all these different delivery services. They probably each have a different carbon level per dollar, and we can just still use the dollars to do it, but we figured out. So you can derive your own emissions factors, or you can use the industry standard ones for the standard stuff. So what generally people do is a combination of that, but then you get into the process model where you really want to know how much fuel was burnt by your delivery fleet, rather than how many dollars you spent on it. Yeah. So it gets complicated. Like the mathematical model here is you multiply two numbers together. It's not a hard model. The problem is understanding which two numbers to multiply together is ridiculously complicated. and people do it wrong all the time. So there is a lot of revisions go on in this space, and there are people that specialize in this. And if you want to get into the complexities of it, there's some real interesting stuff. If you look up LCA modeling, life cycle analysis, it's an interesting area. Okay, thank you.
Awesome. Yeah, thank you very much. Really important topic. Awesome talk. Thank you so much. Round of applause.